Okay, so this video is just going over a couple of questions in 2H on simultaneous equations, but in particular dealing with the speed formula. So this has been as requested as additional support. So I'm making it so everyone is able to use it. Okay, so I'll read the question and I'm going to break down slowly on the steps that I would do to solve this. John and Michael race over 50 meters. John runs so that it takes a second to run 1 meter, to take A seconds to run 1 meter, and Michael runs so it takes B seconds to run 1 meter. Michael wins the race by 1 second. The next day, they again race over 50 meters, but Michael gives John a 3 meter start so that John runs 47 meters. Michael wins this race by 0.1 second. Find the values of A and B and the speed at which Michael runs. So the first thing I'll be doing, because we're talking about speed, we're talking about distance and time. So I'm going to write down the formula, which is speed is equal to distance over time. But to work out the time with what we've been given, we need to be thinking about it in terms of the time something will take will be the seconds per meter that we've been given. So we've been given seconds per meter as A and B, and we're timesing it based on the distance we're told. So for day one, we've got two people, John and Michael. In this case here, they both run the same amount of distance, which is 50 meters. So D is equal to 50. The next thing, we need to think about it, time. Now, time is we're using this formula. So we know for John, it is A seconds to run 1 meter. So how many meters did he run? He ran 50, so it'll be 58. Likewise, Michael is B, so it will be 50B. Their times are not going to be the same, which is why I've labeled it as T1 and I've labeled it as T2. The next part, we need to look at the difference in their times. So it says here, Michael wins the race by 1 second. That means we can look at um, John took 1 extra second. So John's time would be Michael's time, which is T2 plus 1. Now I'm going to simplify this a bit further, and instead of having T1, because I've added more variables, I'm going to make that 50A, and T2 time 2 will be 50B. Okay, we'll stop there for now, and we're going to jump to day 2. We're still talking about the same people, so I've just labeled it as John and Michael. In this part here, we know it's got 47 meters. So we know John has done 3 meters less. So I'm just writing that down as D is equal to 47 for John and D is equal to 50. We're going to use the same time formula to work out the time it's taken. So John, again, his speed hasn't changed. His speed will be A. So I'm just putting T3 is equal to 47A. I kept Michael as T2 because he's doing exactly the same as the previous day. The next part here, I'm going to make this into another formula because again, if we read that second last sentence, it says Michael wins this race by 0.1. So if Michael wins the race by 0.1, that means we need to think about the formula. So John's time would be 0.1 plus Michael's time. From this, I'm going to get rid of my T2 and put 50B there, and I'm going to get rid of T3 to put 47A. So this is the first part. Now, the next part that we need to do is use our understanding of simultaneous equations. So for us to use our understanding of simultaneous equations, so we are then going to look at getting B by itself. So over here, all I've done is I have got 50B by itself by taking 1 on both sides, and then I've divided both sides by 50. The next step we're going to do is we're going to grab our B value and we're going to substitute it into our next equation, which we've got right here. So if I substitute it in, it becomes 50 in brackets A minus 1 over 50 plus 0.1 is equal to 47A. Now we're just going to use our normal understanding of algebra to get A by itself and solve. That means we're just expanding these brackets. So 50 times A is 50A. 50 times 1 over 50 is 1. So we 50A take away 1 plus 0.1 is equal to 47A. We've got two constants that are like terms, so we can make it 1. Negative 1 plus 0.1 is negative 0.9. I will then grab my 0.9 and take it to the right-hand side to make it positive, and I will grab my 47A and take it to my left-hand side. So that will give me 58 take away 47A is 3A, is equal to 0.9. Finally, to get A by itself, I will divide everything by 3 to get 0.3. To find B, I'm just grabbing this formula down here and substituting my A value. If I put that into the calculator, I will get B is equal to B is equal to 0.28. The final step is again going back, and now we know A and B, we can look at the speed of Michael, which is distance over time. So we know the time, and we know the distance. So the distance is 50, and the time is going to be 50 times B, which is then going to equal 3.57 meters per second. Okay, let's look at this second question. So this second question, I'll read it, then I'll slowly break it down. Anne and Maureen live in towns that are 57 kilometres apart. Anne sets out at 9 a.m. one day to ride her bike to Maureen town at a constant speed of 20 kilometres per hour. At the same time, Maureen sets out to ride to Anne's town at a constant speed of 18 kilometres per hour. We're going to write down a rule, looking at distance and looking at time, and then we're going to find the time at which they will meet. So to start off with, we need to think about their time, so their speed. And their speed is given 20 kilometers per hour and 18 kilometers per hour. Now, a mistake would just be to grab this and use it in this form. When it says with the rule, it's talking about t as in minutes. We're looking at kilometers, so per hour. So the first thing we need to be thinking about is how can we get this into kilometers per minute? Well, we know in 1 hour is 60 minutes. So that means I'm going 20 divided by 60 will give me 0.33 kilometers per minute. And Maureen, it will be 18 divided by 60 equals 0.3 kilometers per minute. Now, I will change this one later to 1 over 3 as a fraction. Otherwise, my calculations will be out. So the next part, I'm just going to list down what's happening. Town 1 is where we're starting our calculations, our distance. And to go from town one to Marine's hometown is 57 kilometers. We are using a rule, the speed rule, which I'm manipulating already to become distance is equal to speed over speed times time. Now, if we think about this rule and we think in terms of the speed for Anne, we need to be able to use 0.33 or 1 over 3 as the speed, and our time will just be t. So this part here is our mx in our linear relationship. Now, because it says that we are looking at starting from Anne's town, it means distance so far away from the town is 0. So that's why the y-intercept, it will just be plus 0. If I look at Maureen, well, straight away, we're 57 kilometers away. So that will be the that will be the y-intercept. And secondly, in terms of the speed, we're getting closer. So we're looking at our gradient will be negative because we're getting closer and closer to Annestown. So that means we've got distance is equal to negative 0.3 t plus 57. Now, from this, I am able to use these equations to find what my time will be on when that their paths cross. So that means they're both equal to d, so I will make them equal to each other. Now I've done this, the first thing I'm going to do is I'm going to get my t's onto one side. So it's on your CAS calculator, you can get it straight as a fraction. I would encourage you to, because if I go 1/3 t plus 0.3 t, it will come up as 19 over 30 t is equal to 57. And then finally, I'm just going to divide everything by 19 over 30, and that will give me t is equal to 90. We started at 9 a.m., which means plus 90 minutes will give me 10:30. Oops, I put minutes here, just ignore that. 10:30.